Hey, what's up, guys? In this video, we're going to talk about integration by part. But first of all, we're going to start by proving the general formula. Okay, we're proving the formula. So, this, a general formula starts with the product rule. Okay, so the product rule, I bet you know what it is. It is when you have u, hold on, when you have uv prime equals to u prime v plus u v prime. That's a product rule. Okay, so we can write here product rule. All right, so this here, and written like this, it means that it is a derivative, and you know derivatives are always under the sign of integral, so we can write it like this. It is the integral of u v prime, and this is equal to, this is equivalent to or mean to the integral of u prime v plus the integral of u v prime. Okay, and because it's here under the integral sign, okay, we can integrate it, and when you integrate it, it gives you u v, okay, equals to the integral of u prime v plus the integral of u v prime. All right, and what we're looking for is this formula here. Okay, so we can write, this means that the integral of u prime v equals to uv minus the integral of u v prime. Okay, and this is here the general formula of the integration by part. So in this example here, integral of ex sine x dx, we will use this formula. But first of all, we need to change variables. Okay, so this is what we will first let u be the sine. Okay, u be the sine of x. Okay, this means that a derivative will be the cosine of x, right? And v will be the exponential of x, and the derivative dv equals also the exponential of x. All right, so now we will apply the formula, right? And it was saying that it is uv minus the integral of u v prime. Okay, this integral is that. Okay, so let us just replace it here. So that's going to be, if you say uv, we will say, let me just put some arrow here to make it beautiful. We will say it is uv, okay, minus v, uv minus v, okay, times du. Okay, let me put just minus v here. Okay, so this is going to be like this. This is what we're going to do. It's going to be, we said uv, and uv is the exponential of x, sine of x, okay, minus the integral of v, and v is exponential of x, times du, and du is the cosine of x. Okay, this is our first derivative. We're going to do that twice, and this is the next derivative is going to happen right here. Sorry, we're talking about integration, so this is our first integration, so we're going to do that twice. In our second integration, we will let u be the cosine, okay, the cosine of x. Okay, this means the derivative of u here will be minus sine of x, and v is the exponential again of x, means that its derivative will still be the exponential of x. As you can see, this part of our work is integrated already, so we're dealing with this one now, and this is what we're doing. So we first did this integration to have this one out of the integral sign, and now we did it with the second part, okay? And the second part we're working with is this one here, okay? So let us use our formula here once again. So it's going to be uv again, okay, minus the derivative of v du. All right. I mean, just like we had it before, we do the same thing. uv minus the integral of v, okay, the integral of v du. Okay. So now let us continue to replace it. But first of all, we're going to keep this one here just like a side. We just say that. Let me take an appropriate color for that one. So this one here is gone already. Okay, sine of x minus. So we're taking this one here, we integrate this one here, and we're taking this one here, right, in our integration. So we said it is uv. It means it is the exponential of x cosine of x. That's uv minus the integral of v ex times du, and du is minus sine of x and dx, the whole thing in a parenthesis. So let's just work it out of the parenthesis. Okay, we're gonna have here ex sine of x. This is gonna be here minus ex cosine of x, and we have the minus here coming to this one here, minus time minus, we got the plus, and bringing this out of minus on it, it gives us minus the integral of ex sine of x dx. Okay, so now remember that all we're doing here is we are integrating this way. It means that all we have in here is equal to equals to equals to. This is this integration here coming here and there also. Okay, so we can just write the integral of ex sine of x, I can even put parentheses if you want, dx equals to the whole thing here, ex, let me just change the color, take a black, okay, and it's one here, okay, equals to the whole thing here, ex sine x, and put some parentheses, make it beautiful, minus ex cosine of x minus the integral of ex sine x dx. Okay, now you can see that these two terms here, this one and that one, they are alike. Okay, the only difference is that they are situated, each other, I mean, on the two part of this equation or the integral here. So what we're going to do is that we're taking this one here to the other side. Okay, so it's going to give us, if we take this one here, it's going to give us, let me just take the blue again and make it beautiful, that we will have 2 times the integral of ex, because it's going to take the plus, the plus sign, sine x dx equals to, now going back to the black color, equals to ex sine x minus ex cosine of x. Okay, now we would divide the whole thing by 2 here and by 2 there. Okay, and this is going to give us the integral of ex sine x dx equals to 1/2 ex sine x minus ex cosine of x. And we can even use ex here as a common factor of both, right? So that's going to give us finally the integral of ex sine x dx equals to 1/2 ex parenthesis as a factor sine of x minus the cosine of x. Okay, and here we're done with our integration, and this is our final result. Okay, so we will say that the integral of sine of integral of exponential of x sine x dx equals to 1/2 exponential of x times sine of x minus cosine of x. Okay, okay guys, that's it with this integration by part. Okay, we first started with the to proving the formula. uh, we had the general formula, and then we did this example to to better understand how it works. Okay, so in my next video I'm gonna do some more excited exercises. Okay, just tune on. See you alligator. Bye bye.